Hello and welcome to our first ever webinar at Tech Leaders Academy. Tech Leaders Academy is a place where tech professionals and leaders come together to learn more about how to develop their career. That's why we offer a lot of training. So if you're interested, check out our website. But today we're going to do a talk in depth about MLOps, ML Lifecycles. So if you came across our live streams in the past, you may be at our Tech Roads Uncovered format that is Sarah hosting every Thursday. But if you check the calendar, today is Wednesday, so we don't do Tech Roads Uncovered today. We will do a different format. It's the first time we do this, and it's a webinar. So, Sarah, would you like to introduce more about our guest today and what we're talking about?
Yes, sure. Hi. Today's topic is about MLOps, ML Lifecycles, and how we can use standardization in order to build, deploy, and maintain machine learning services more easily and faster and better and everything else. I think we will discuss that in more detail soon. And yes, the talk or this webinar is called From Data to Deployment. And it's because we have a special guest with us today. He is very passionate about this topic. And if you follow him on LinkedIn already, he's writing almost every day about machine learning operations, about life cycles, and how you, as a data scientist or data professional, can optimize your work. And yeah, recently he also published his first ebook about this topic. So it was time for us to bring him to this show here. So I'm very happy to have him here today. Here is Agostino Calamia. Hello.
Hi, everyone. Thanks for having me.
Hi, Tino. So the short form is totally fine, I think.
Yeah, definitely. Call me Agostino, Tino, both works perfectly.
So really happy to have you here with us today so that we can discuss like ML ops topics and ML life cycles in more details. Maybe before we start into the topic, would you be so kind to also introduce yourself just quite briefly so that we can get an impression of you?
Definitely. Yeah, so as you said already, and I think your introduction was probably even better than mine is ever going to be. My name is Agostino. The short form is Tino, how I think most people call me. I'm currently senior data scientist at Shopify, where I mainly take care of basically the entire data lifecycle. So we start from the very beginning, build our data models, build ML models, monitor them, and try to have as much impact as possible, where we mainly focus on sales operations or key account management and try to support them. Before, I worked in a fintech that is called N26. So it was a completely different industry. Very interesting too, by the way. And from that experience, I understood that I'm really interested in ML ops, ML life cycles. What exactly this is, we're going to talk about it in a bit. But then as you said, I decided to condense all my knowledge into an ebook that hopefully helps a few folks out there. And yeah, that's basically what I do and what I like.
Really cool.
Right.
Thank you very much. And currently you're living in Barcelona?
That's
In
correct.
Spain, yeah.
Exactly. I'm originally from Germany, but after a few hard Berlin winters, I decided to move to the sunnier side of Europe.
I
I
can
think that.
understand that.
Yeah, me too. Me
Definitely.
too. Yeah. So maybe also to describe a little bit what we are going to do right now. So we plan to have a short introduction to lay the foundation so that also the people that are watching us right now have the opportunity to get a basic understanding what ML ops and ML life cycles are. So you will quickly share your screen soon. And by the way, before I forget it, if there are people watching us right now live, of course, you can ask your questions. Just put them in the chat in LinkedIn or YouTube, and we will then, put them into our questions books, and we will get you covered definitely. Yeah. So, Tino, if you mind or don't mind, it would be really cool if you could share your screen and
Perfect.
then.
Yeah. And I'll share my
See.
screen, go into presentation.
Yeah.
So you should see it by now. If not, please let me know.
I see it, but I think Sebastian and me, we are interacting too much. Yes. Well, we see for now a black screen.
Oh, really?
Now it's there.
Seems to work.
Yeah.
Perfect. Okay, great. Then I'll kick it off. So as we said already, the topic I'm really passionate about, I wrote the ebook about, and the topic we're gonna talk today about is from data to deployment, which basically covers how we can build standardized machine learning life cycles fast and easy. And in those few words, I used already enough words to confuse people. So that's why I think it's really important to clarify a few things before I explain what I mean and why I think it's important.
Oh, now he's gone.
Oh, we lost him.
We lost him. I think that's the risk of going live. So I think the internet connection got lost. Yeah, we don't have a backup, but I think he's just joining back. He's just dialing in. Let's see if we can.
Okay, can't see you right now.
We see that we have a very unstable internet connection right now. Yeah.
Well, that can happen if we do it live.
That can happen. It never happened before, actually. So with my live streams, but we also never used to share a screen.
That's
so
right.
It's the first time that we do screen sharing, and that's live. Yeah, let's see. There he is.
Am I back?
Yeah.
Now you seem to be back.
Okay, I'll give it a shot. Sorry, I didn't know what happened here. Can you see my screen now?
Yeah, should be up soon.
I see it. Well, actually, for me, it's not possible to read the screen. I don't know how it's for you, Sebastian.
No, it's blurry. I will just try to activate it again, but yeah, it's kind of blurry right now.
Oh, okay, interesting. For me, it's obviously sharp because I'm sharing.
I think it's better right now. Yeah, it's getting a little bit better, but I think we have to deal with it right now.
Okay, I'm not sure. Like my internet looks like it's working. Not sure what's happening here. So yeah, I can also try to continue with the blurry slides and try to make it more appealing through audio.
Yeah, that would be great.
So basically, what I was saying is that the standardization is a process that every company should have, but still leaves room for individuality. So what that means is that you can ship results more reliably and as well faster with like a really high output quality if you have processes in place that do a few checks on the way that make sure that people are actually really doing the same in the same quality. And how that looks like, every company has to figure it out for themselves. So they have to develop their own playbook of how to follow these rules. And the interesting thing I noticed working for Shopify is that it can work in a big company, but in my time before at N26, I also figured out this can also work for fast growing companies. So scale up, startups, whatever you want to call it. And that's when I thought, okay, it's actually really interesting, that topic, and people should talk more about it. Now, I've used the terms MLOps and ML Lifecycles a bit. I think they are not clear to everyone and can also be interpreted differently. So the definition you find here is basically what I understand talking about these terms. So MLOps for me is basically the practices and methods for developing, deploying, and maintaining machine learning models. And I think what's interesting here is that developing, deploying, and maintaining already covers everything that is related to a machine learning model. So from the very beginning to the very end, to surfacing the results and keeping an eye on them. Then the second term is machine learning life cycles. And here the important part is that's a systematic and iterative process that covers all these phases that I just talked about. And again, here, the systematic part is really important, because you want to have something in place that people can follow, that people do similarly, to ensure certain quality, a certain speed at which you can ship. So you might find different definitions of those, but I think I can work really well with the definition of these two words like that. Okay, how does it actually look like? How should a machine learning lifecycle look like? What should be considered? The next slide, I hope it's sharp by now, shows the process a little bit. So we read it from the left to the right, where we have three major blocks. On the very left, we have the design block. So that's also the first phase of a machine learning lifecycle. Then we have in the middle, the build phase. And on the right, the monitoring phase. So basically everything that happens after deploying a model, or while deploying a model, actually. And the orange bars underneath these three blocks are sub-steps or parts of this entire phase. And I'll explain a little bit why I think these three are especially important, and what I think can be standardized and why it's helpful. So starting on the very left with phase one, the design phase, I think it all starts by building the right team. That sounds really trivial, but I think everyone has been in projects where people joined and left. Some people were more active, some were less active. And I think finding decision makers, the right stakeholders, is so important, and a standardized process. If you, again, have a template of what you need in any process, maybe a legal counsel, maybe someone from business operations, you need backend engineers, you need product or program managers, whatever it is. If you have a list and you can just tick off if anyone required for that project is really on board, then you can speed up this process significantly. Same goes with collecting requirements. I think, especially from a technical perspective, we as technical stakeholders think we know what is required, but then we talk to the business and we figure out, what we thought is actually not the right solution, because we cannot meet their needs. So collecting technical and business requirements is a crucial part of the design phase. Then I think, for me personally, this is the most interesting part. The third orange block is the ML design, which is then really going into proposing a solution, figuring out how we can satisfy the technical requirements and the business requirements that we talked about earlier. How can we implement that into our application, and how can we design it in a robust way? And all of that, in the end, can be condensed or put together in a condensed version, which I call project proposal, which is basically just a summary of everything before. So you write down what is the problem that we're trying to solve, what is the background, what is the proposed solution, how do we want to approach it, what risks are we facing, who's involved. All of that is basically the one source of truth for all other stakeholders. So if anyone is interested in your project, you can send them this project proposal. If you want to reassure that you understood everything correctly, look at the project proposal. And I think with a clear structure of that, you can already align all the people on the same idea and communicate it easily to other stakeholders. Moving now, after you've done that, and I think that often takes a lot of time, so you want to spend just a little, or as little time as possible on this, you want to move to the build phase. I think that's what everyone is excited about. People talk about it a lot. When you check social media, many people talk about mainly the build phase, because it's exciting, obviously. You want to have our first sub-block here is a feature store. You want to be able to have features already in place, data that you can retrieve easily. The reason for that is that, first of all, if it's in our feature store, so basically a place where we can access data in a centralized way, we know it's most likely that someone checked it and it's correct, it's cleaned, it's reliable. But at the same time, if I want to build a model and I already have a bunch of features calculated in my feature store, I can easily use them without spending much time on building a training data set and experiment a little bit faster with my machine learning model. Then it goes over to data quality checks, something I'm personally really passionate about. It's a little bit boring, but it makes your life easier if you do it right, because often it happens that you build your model, it has amazing results, it has like a great accuracy, and then you don't trust it because you're like, this is the first approach, it shouldn't be that good. So you dive into the data and you figure out, okay, there are actually some missing values, there are some issues, and then you have to iterate and iterate and iterate until you have figured out all the data, issues in your data, basically. And if you have automated data quality checks in place, that will be avoided from the very beginning. And therefore, this is definitely a hack that everyone should implement to speed up the development. Then also model evaluation, similar to the requirements earlier, has a technical part, or rather a statistical part, and also a business part. So you want to evaluate your model based on statistical performance, ROC, accuracy, etc. But at the same time, how much business impact does it have? And that again depends on the use case. Do we want to increase revenue? Do we want to reduce costs? Whatever it is. So yeah, that's an important part. And figuring out the key metrics before you even build your model and setting thresholds that let you think, okay, my model is actually good enough to deploy it. That has to be done upfront, and it should be written down somewhere, and everyone should align on that. And then the last part is a model store. So with model store, I basically just mean a place where you store all artifacts that have been involved in your model development. So that means your trained model, your training data, the evaluation data, the results of the evaluation, maybe a Docker file that creates this environment so that you are able to reproduce it. And again, the reason here for to use that is basically that if you want to do a second or third iteration, you can compare it to your previous iterations. You can understand, what did I do the last time or the time before, or what have we done 1.5 years ago, and how did it perform? And this reproducibility just helps you understand, what did we do in the past so we can improve now upon it. So yeah, these were my main aspects for the build phase. After that, you are obviously interested in developing or deploying your model to production so that whoever wants to use it can actually use it. And for that, my two main ideas, or my main focus, would be on a good alerting system, because if something fails, if your output doesn't look like it should look like, if distributions shift, if maybe something breaks, you want to get an alert right away. Sometimes you need to fix it ASAP, right? So if we are, for example, talking about chatbots, you want your chatbot up and running all the time. So you should have a very stable infrastructure plus alerts. If it is down, you can react right away. Sometimes it's not that urgent. If something only is needed once a week, once a month, and it fails and is not directly needed, you can also get a warning and take care of it tomorrow, the day after, whenever you have time. So I think alerting systems are really underestimated nowadays, because it's really not clear how people should act upon failing services. And then the last topic I'm going to talk about today is rollout techniques. So when you want to roll out a new model, there are different ways of doing it. So you build a great model. You think, okay, it's really amazing. I want to show it to all the customers right away. But you don't know how your model behaves in the real world, right? So you tested it in a certain scenario, but you want to understand, how does it actually work with my customers? So maybe you want to roll it out to only 10%. And after 2 weeks, if everything is fine, you want to roll it out to 20%, then to 50, then to 70, and then a full rollout. Maybe you want to have it in shadow mode in the back and observe how it would behave if it would be live. So there are many ways of doing this, and some are more suited than others depending on the use case. So that has to be considered upfront as well, and ideally already thought through in the very beginning where we design the ML system. And with that, I conclude a very small machine learning lifecycle. So this here is a really basic example. It was really high level. There are many nuances to all the single aspects I talked about, and a few additional ones, obviously. And again, as I said earlier, this might be relevant to a few teams, but other teams have slightly different life cycles. So very small startup, maybe they don't have to talk about how to build a team because they're a 5-team startup. So it's very, very clear. Maybe quality checks in big companies are already implemented or alerting systems. So you don't have to think about it. You just have to plug your model in and it's automatically done. And nevertheless, it's important to keep all these things in mind, to have a mental checkbox or checklist or a written one, and just ensure that you don't miss any part of it. Because if you have all of this in place, the second iteration, if you already know how does my team look like, how should I structure my project proposal, on what metrics do I evaluate it, your second iteration is already going to be faster, and the third one even faster. And only, in my view, if you iterate fast and if you ship fast, improve fast, then you will survive, especially in difficult macroeconomic situations like today. With that, I would hand it over again to the two hosts because I think I talked enough and tried to explain why I think standardized ML life cycles are beneficial.
Great, thank you. That was a really nice and concise overview. What's kind of interesting for me, I have like a software development background, and I see a lot of similarities to what a lifecycle in software development is basically about. But I also see some key differences, which is obvious because you're not dealing with software, you're dealing with data, we're dealing with machine learning models. How did you came up with this lifecycle? Was it like out of your experience, or was it inspired by some pre-existing lifecycle?
That's a good question. So how I came up with my ideal life cycle is I put together all the steps that I have performed, that I've seen other people perform, or that I thought, okay, these could be really crucial steps in a life cycle, but like no one ever does it. For example, I skipped it now as well, but ethical considerations, ethical AI, that's a big part of it. I didn't mention it yet. And I know that very, very, very few companies only do it. But I think personally it's important. So what I did is I created a really long checklist of steps that should be performed. And the idea is that depending on the situation and the team, people can just strike out a few of them and shorten it a little bit. And yeah, long story short, I basically, whatever I did and found useful, I put it in there. And then I also heard from other people who I talked to about things they do that are important. And that's how I came up with this life cycle.
Great, very inspiring.
Thanks.
We got our first question that I would like to bring on stage.
Yeah.
It's from Rana. Who is, in your opinion, responsible for the feature store? Is the main owner the machine learning engineer, the data scientist, or someone else? Good question.
That's a tough question. I wish I could give an easy answer, but as so many times in life, it depends. I don't like that answer, but it depends on the organizational structure. So I would say, in a big company, let's say Shopify, you would have a dedicated team for that. I think that only makes sense because if you have the resources, you should have a dedicated team to do this kind of work. I'm not only talking about maintaining a feature store, but I'm talking about maintaining data tools, for example. It doesn't have to be a feature store only, but ideally you should have a team that builds tools or maintains tools that support data scientists. So that about the infrastructure. And then plugging in all the features can either be done by data engineers, machine learning engineers, or data scientists. It depends a bit. So I think, for example, topic-specific features that have been engineered, like, I don't know, ratios, year over years, comparing whatever, should or could rather be done by data scientists. Really basic data that gets ingested can also be done by data engineers. So I think there's no yes or no. I think the basics, like the infrastructure, should be handled by a specific team. Maybe basic metrics or company-wide metrics could also be handled by data engineers. And then when it comes to topic-specific metrics or data points, that should be handled by the teams and data scientists. that's how I would ideally see it.
Mhm. Yeah. Thank you for your question, Hannah. Hope Tino was able to answer your question. If not, just write us in the chat and then we are going to discuss even further. Meanwhile, I also have a question, Tino. Maybe do you know this CRISP DM model that is widely used in our industry and how to come up with data science projects in general? How would you compare your idea of an ML lifecycle with this kind of standard that is, widely used?
That's a very tough question. I've learned about CRISP-DM. I'm not 100% familiar, but I know the idea, definitely. I think CRISP, like the main difference is that I think the framework I try to describe is a little more detailed in certain areas and in others less. So I think the machine learning lifecycle is a part of a CRISP-DM framework, but I think it doesn't cover all of it, right? So also this iterative process that you have in a CRISP-DM framework, I think I didn't cover it fully. It's more for me specifically for one model, whereas a project or a data-related project is a little bit bigger, a little bit broader. And I try to focus really on the machine learning part. So that's how I would differentiate it.
Yeah, I'm quite familiar with this CRISP-DM model because back in the times when I also used to be a data scientist, we had it everywhere, and we already always tried to get along with this standard, and it has a huge amount of data understanding and data preparation in this cycle, which it was not included now in your representation, but maybe it was included but not mentioned by you. But on the other hand side, I think this CRISP-DM is solely focusing on technical parts like the data preparation, data modeling, and the deployment. And you also had this more, how to say, soft parts like the product owner part, like requirements engineering, and also what else? The feature store, for example. Okay, that's technical, but it was not included in the model. Yeah,
I think that's actually a really interesting point that you mentioned, like understanding the data, getting into it. And I think that's what we as data scientists spend a lot of time on, because you have hundreds of data sources. You look at them, you want to understand what do they actually do, how do I use the data, and I think that's for example, the feature store could be one part or one place of it where this could be solved a little bit so that the data I access here is actually reliable. Ideally, you have some instructions on how to use it so that you know what you're doing, but you have also enough trust in your organization that you can just use it without applying 5,000 checks yourself, doing cross checks, etc. And I think for that you just have to have a really strong foundation that is technically well done, but at the same time also has a really good documentation, because you have to understand what you're actually using. That's actually really interesting. It totally makes sense.
I think your model also captures better what we are dealing with right now. We're not talking about data just for technical purposes. We're talking about data products. We're talking about bringing like software products together with machine learning. And we're always having like a customer in mind or a user in mind. We always have a product thinking approach right now. And I think this is what your model is basically covering better.
Yeah, that's how I prefer approaching problems, because I think when I started data science, I thought, okay, it's really cool to build a great model, really sophisticated model, etc., etc. But now I think or at least for me personally, it's way more interesting to understand what do my stakeholders or the customers, because you can have external or internal customers, what do they actually need and what do they want? Maybe it's also just a dashboard. Maybe they don't need a machine learning model. And then give it to them, see how do they interact with it, get back, and then reconsider what you actually wanted to build. I think that's exactly what you said, that it's actually more a data product than pure modeling, which I personally prefer.
Yeah. Yeah, I see it the same way. So I think your view on this whole topic is already a little bit broader than
Hmm.
when you start into this area, or when you
Definitely.
completely specialize in something like, I don't know, language modeling, NLP,
Yeah.
and so on, and you're a very specialized machine learning engineer or a data scientist specialized on NLP. I think that's different to, I would say, a more generalized data science approach, and maybe also how you see your role in your team right now. Cool. Yeah, I have also one question regarding what would you say is currently the most challenging, or what are the biggest challenges right now in machine learning development, and how could this kind of framework how can this framework help us to maybe overcome the challenges?
Interesting. That's another good question. I think starting with what's not a challenge anymore is, in my view, building machine learning models. I think
Mm.
we all have so many packages. I work mostly in Python. There's so many packages out there where you just choose a model, you fit your data, and you're good to go. So you don't need that statistical knowledge anymore that people needed years back. So I think, first of all, that's already solved, which is why I think that's not the biggest challenge anymore. In my view, the two big challenges are actually getting your data right, like collecting the right data, cleaning it, making it available all the time, because I know that's also a tough one. And yeah, democratizing it. So that means everyone who needs access also should have access to the data they need. I think that's a big topic, because based on that, you can build your training data, which is actually the hard step, figuring out what is actually a signal, what is noise, what do I want to include. I think that's the tough part, and that's what we spend most of our time on. And then I think just building a right product is the real problem, because often you think you build something and it will solve a certain problem, but your approach might not be the right solution. Sometimes you should do, I don't know, an A/B test first to validate your hypothesis, and only if your hypothesis is validated, build a model. Many people start with building a model because, let's take churn, for example, as example. You build a churn model because you think, okay, if I create a churn score, we can avoid churn. But we don't know if outreach to customers who might churn actually has an impact. So getting this process right, understanding where should I start instead of investing time and resources into a machine learning model directly, I think that's what people are struggling the most with. The rest, whatever comes after, is a little bit easier, because you have tools that help you. You have either modeling tools, or also, I don't know, look at Google Cloud Platform. It's so easy to develop a model or to deploy a model nowadays, that I think the part before, the integrating into the business, getting the data right, that's the hard part.
Yeah.
Quite interesting. I think the same. I mean, we are like having a lot of headlines about tooling. Like every day there's new tooling that is coming up and it's making things easier. Sometimes harder, but mostly easier. And yeah, it's basically taking all the work from us. So we have to make sure if we build something, we're building the right thing. And I think this is the hardest challenge. So as we come together before, we have to build the right product, and this is basically the hardest challenge to face.
Yeah, definitely. I mean, the best example is actually all the GPT models floating around now, because you don't like to use GPT, you don't need a data scientist anymore, right? So there's an API. You can build, with a software engineer, you can build something that people can use, plug it into a GPT model, and then you're good to go. So I think the focus will shift in the next years for data scientists a little more, and there will only be very few companies building crazy models. So that's my take.
Yeah, especially training models on this rich data. I think that's almost impossible. No one has this data as the big companies, tech companies, and when they're already providing the models and you can integrate it in your service, or maybe also remodel it in a way with, I don't know, a small amount of data. I think that's definitely the future that we actually, I've already seen that trend some years ago when all these machine learning services on AWS and Microsoft Azure came along. But I think now it really crashed in with this ChatGPT, especially with this language modeling.
Yeah, definitely. Totally agree with that.
I have another very specific question to you, Tino.
Great.
Coming back to the feature store, how can you imagine, how does the feature store look like? Is it like part of a data catalog? Is it basically a markdown file, or is this a Notion or Confluence page? How do you manage to make it accessible and maintainable?
Yeah, I think there are many complex versions of it, or really advanced versions of it out there. There are providers who give you tools where you can easily plug it into your data warehouse and then specify a few rules. But I think the easiest solution you should build in the beginning, or you should think about, is basically just one big table that has per customer a few metrics calculated. And per column, you have a markdown file or a YAML file that describes what each column does. So let's say we stick with the churn model. We have a part in our feature store, so let's see the feature store as a collection of tables, of many tables that are domain specific. So the one is churn related, the one is order related, etc., etc. And then you have basically big tables that are calculating metrics per merchant per day, for example, or only per merchant over the entire lifetime. And each of these columns has a in-depth description, so the user actually knows what they're using. And I think that's how you should mentally see a feature store. It's basically a structured way of engineering your data or your features. And how it looks like it, you can use a pre-built software that's obviously more advanced, or if you want to build it yourself and save the money in the beginning, you can also just build a set of tables, domain related, that does the job.
All right.
Yeah. And maybe to add up on that, I think that could also help not only machine learning models, but reporting as well. If you have a centralized place with data points, and everyone, if you want to look at a revenue, everyone looks at the same revenue number, and not department A calculates it in this way and department B calculates it in this way, then you also know, okay, we are all looking at the same numbers and the results are comparable. That just as addition.
Yeah, it promotes this democratization of data inside of the company. So whoever wants to access it knows, okay, where to get it and what quality can I use it for my reporting, for example.
Yeah, exactly.
Yeah, I think from the BI perspective, I mostly hear about that as a data cataloging system, or as a so-called single point of truth. It can be also it can also be a simple data warehouse, and you have some kind of I don't know, easy access to it in order to view the columns and to get a description, a written description, what this column actually means.
Yeah, I think there are more sophisticated solutions out there. Totally agree, but I think most companies should, like, if they get this data catalog with in the data warehouse right, I think they're doing so big steps that they are set for a while. So I think the majority of the companies do not need a really advanced feature store.
Yeah. So for whom would you say is it most valuable to have a framework as you showed us today to work with? Is it something that you can already use or that you think about in your earlier data science career, or is it something that you mostly deal with when you're already in a maybe leadership position or in a product owner position?
Yeah, I personally think people who start their data journey, they should not focus too much on this. I think they have different stuff to work on. There's technical improvements. There's project management. There are so many things that overwhelm you easily that this was not the target group I was aiming for. So with that, I was more aiming for more senior data scientists, ML engineers, whoever else, and leaders, because there are obviously two sides of it. One is more the technical side, right? So really evaluating the model, being hands-on, maybe deploying it, monitoring data, setting up alerts. That's really hands-on. On the other side, you also have the entire stakeholder communication, bringing people together, communicating the results, freeing up resources, which is more the leader and management part. So I think it makes sense if you are working on a more important project or maybe a little advanced in your career. I think that's when you should focus on having this system, because with that system in place, you help your more junior colleagues to actually have a solid impact.
Yeah. I think so too. Well, actually, when I started with my data science career, I was not really worrying about any stakeholder requirements. I was so deep into learning Python, doing SQL right, getting all this algorithm stuff in my head. And there was no place for anything else than that.
Yeah.
But later, when I was also in this leading position of projects, when I realized that the technical part is one thing, and that's most of the time not the problem when something doesn't happen. So it's oftentimes something different. And I also started to think about what it actually is. And it was oftentimes not this hard technical part, but rather some human interaction, some standardization, some processes that were missing, so that we did the same mistakes over and over again. So I can definitely emphasize your opinion on that I think this kind of approach and processes is something that you most of the time deal with when you're more advanced in your career.
Definitely. And if I think back about my early days as data scientist, if I would have these processes in place, if I would have known what are the metrics I should actually evaluate, what is actually important, maybe who are the stakeholders I should talk to, all of that, I could go on for a while. That would have been so much better for me. It would have made my life so much easier, and I could have focused on the actual weaknesses I had back then. So I think if more senior people take care of this, it also improves the impact more junior people have and makes their life a little easier.
Yeah, definitely. Great.
Yeah, nice.
All right. Should we sum it up? What do you guys think?
Yeah, why not?
Great.
All right. Tino, would you like to conclude something out of our talk? So we talked about who is it for. We talked about how your lifecycle model is working and what are the different parts of it. So maybe you can summarize why to standardize. What are like the key benefits from it?
Yeah, definitely. So first of all, again, I want to repeat this. Standardization doesn't mean there's no room for individuality, right? So standardization in a context of your own company is meant by that. And I think that just helps to be aligned with other data scientists and engineers. But at the same time, it also speeds you up because you know what to do, you know what to look at. There are processes in place where you can just tick off a box and you know, okay, I've done this, I've done that, instead of like mentally walking around, not knowing what to do, where to look at. And I personally think if there are processes in place that you can orient yourself around, you are mentally more focused on the task that you should actually do. Your output will be higher quality and will be delivered faster. With faster delivery, I think you learn more, you have more impact. And that's why I advocate for it.
Great. Thank you very much. So one important note from my side, we are basically kickstarting a workshop based on what we were talking about. So it's all about the ML lifecycle that Tino described. It's all about the things he wrote in his ebook already. And we are going to kickstart a workshop that is basically a 4-hour workshop with Tino as a host. And it's basically made for everybody who is in this senior position or this leadership position, as you mentioned before, and want to standardize and find better ways how to deal with this life cycle, how to get inspired, how to improve in the different parts of the process. So if you're interested in this, we set up a waitlist on our website. Just go to tech-leaders.academy, and then you will find his workshop. I think it's the third one in the list. Click on it and sign up for the waitlist. You will also get a discount if you sign up right now for the waitlist, and we will let you know as soon as the workshop is going to start.
Perfect. Looking forward to
it. Me too. I'm also looking forward to the first workshop, especially, and to host it, and also to increase our knowledge. Maybe to finalize that, thank you very much for the insights, for showing us around, like to give us an impression what ML Lifecycles actually is. I still have many questions, but I think this one is maybe better for another session in the future, or maybe we can also write some kind of a blog post in order to also describe it in a little bit more details if you would like to. And yeah, I really enjoyed it. Thank you very much for coming.
Yeah, thanks for having me. Thanks for organizing this. And thank you to everyone who joined and listened to all the things I said.
Yeah, maybe one thing to add from my side. If you're watching live or watching this later on, just put down your comments on YouTube, on LinkedIn. This is like a great input for us doing a second session. So feel free to add your comments below. Then we know what you want to know, and we can start off a second webinar.
Perfect.
Yes, true. So then, thank you very much, everyone. Also, thank you outside in the world for joining us here today, and see you the next time. Have a nice evening. Bye-bye.
Thanks, everyone. Bye-bye.
Bye.